to all of you. I'm Riddhi Jain from Atal Innovation Mission, and I welcome you all in the second episode of our Knowledge Hub session. In our first episode, we covered the identification and construction of problem statements specific to School Innovation Marathon. And in our second episode today, we are going to cover the prototyping for School Innovation Marathon. To cover this topic, we have with us Sri Gauri Dutt and Sri Kiran Kumar ji, our veteran regional mentors of change who need no introduction. So, without delaying any further, I would like to invite first Gauri Dutt sir to take it forward. Thank you.
Good afternoon to all mentors. Good afternoon, my colleagues. And it's a pleasure to be back on the Knowledge Hub sessions. And I start sharing my slides. I'll just stop my presentation. Let's see. Okay. I hope my screen is visible.
Yes, sir.
Okay, good. So we are here to talk about prototyping for the School Innovation Marathon. And as you know that the last time in the last session, we discussed about ideation, how to select the idea. And I hope most of you have helped your mentees in selection of ideas in line with the themes in the School Innovation Marathon. So the themes are very important here. And once you have the idea, the next step is to create something. So creation is prototyping. So we are going to have how to prototype, what is prototyping, etc. Okay. So here's the agenda. First, we'll talk about what is the prototype. We'll define the prototype and give some basic information, followed by a list of objectives of why we are prototyping. What do we want to achieve out of the prototyping? So a list of objectives will be presented. Later, we'll have characteristics of a prototype. So what does a prototype look like? How does it behave like? So we'll look at that. Then what is the process of prototyping? What are the stages in prototyping? What are the important stages which an innovator or a creator must follow? We are going to discuss that also. And at the end, there'll be tools and materials. So if you want to create any physical shape, you require tools and materials. So why we are talking about tools and materials here is, we have two types of prototyping. We have a physical prototyping and we have a digital prototyping. So I'm going to cover the physical prototyping aspect, and Mr. Kiran Kumar will cover the digital aspect later. So that's the reason, because if you want to create something physical, you need some tools, you need some materials to give shape to objects. So what is a prototype? A prototype is an early stage sample, model, or release of a product created to test a concept or a process. So we selected an idea for the marathon. We had a concept. So what we are going to do now is to move further into prototyping, which means that how to give shape to our idea, how to give shape to our concept. Very important aspect here is, I must tell you from my experience that you may have the world's best idea. You may have a very amazing idea. You may have a very, very inventive idea. But unless you are able to communicate this idea in a proper form to the intended users or the targeted users or the audience, your idea becomes useless. So most important aspect of one's work for success is to communicate in a nice way. So if you are able to communicate in a proper way, half the job is done. So here is a prototype. What is a prototype? It is communicating your idea or your concept. What did you think in your mind that something new or something amazing you are creating? and how do you communicate this to the user. So that's the property of a prototype. It's a means of communication. That's very important. Next, we move to the objectives. So validating an idea or a concept to solve a problem. Now you chose an idea, you want to solve some problem. So what happens is when you when you have an idea or a concept, you either have it for a problem solution or you have it in out of the box design. Okay, so most of the 99% of innovation that is happening in the world is to solve problems, because things have already been created. We have some existing objects, we have some existing processes, and how do we make sure that these processes can 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 be worked on a solution? How can we make a solution? How can we make a solution for the problems? That's more important. So when you are creating something, when you're creating a prototype, it has to have a workability. It should work. That is how you can convince your target audience or your target buyers that, look, here is something that works. Here is something that solves your problem. Okay, so very important thing here, problem statement. So if you have a problem and a solution, most important is first to define what is your problem statement. Because if you are not able to write down your problem statement, you will not be able to create a nice solution or a workable solution. So a very important aspect is write down your problem statement. Not only write down, also share this problem statement with your users. Let them say that this is the problem they are facing. So how can you get a user confirmation on a problem statement? That's very important. That will lead you to a proper workability of your prototype. Next is explore and validate user need. So you all are familiar with design thinking. In design thinking, you have a user interface. You interact with users very often, not once, many times. And therefore, you have to explore and you have to get the validation from the user. If the user validates, then you are on the right track. The user is actually giving you a direction of movement in your prototyping process. Next, demo the benefit or the solution. So when we create something, creating it and keeping it in our room is of no use. We have to finally demonstrate it to the users or to our audience to show how this solution is actually going to benefit the users by solving their problems. So solution of a problem in terms of benefits that are delivered by the solution is very important, and that is possible when you demonstrate your prototype. So once you've created something, you're going to talk about it. So what we are doing in the Tinkerpreneur competition, there was a pitching. So people have to create a video. So here also in the School Innovation Marathon, you are supposed to have a prototype for sure, and you are supposed to explain this on a video. So your benefit of the solution should be demonstrated to the users. Involve user feedbacks. So as I said earlier, ask the users what is their feedback. Each time you have to work with the users, because it is the users who will actually define and stamp your innovation. So the best thing is to create a feedback form. We all buy a lot of stuff from the market. We buy some appliances, the home appliances or whatever from a good brand. And after we have bought, we receive a mail or we receive a phone, an automated phone conversation wherein they ask you for your feedback. So feedback is very important. Okay. So design a feedback form. sometimes what happens is when you ask a buyer, a customer or a buyer, what is your feedback? He may be busy, or he may not strike, something may not strike to his mind what to say. But when he has a feedback form in front of him, there are specific questions. Then he tends to answer those questions, and then he probably tends to write more than what you have asked for. So if you really want a good, an important or a nice feedback in terms of useful feedback, then you should design a feedback form and share it. So your ultimate aim out of this prototyping is to gain user trust, which means that the user must display that he trusts that you have the competence, that you have the resources, and that you can create the right solution, and that you are moving on the right track. So ultimately, it is the user stamp which you need. Once the user has stamped your prototype, you don't have to worry at all. It's a winning prototype. You are going to create a winning solution for sure. So gaining user trust is utmost important. What are the characteristics of a prototype? So when you create something called prototype, it is not a fully workable product. It may have limited features, limited functionality. Okay, so it cannot be a fully functional product because you have not completed the product manufacture, or you have not completed the making of the product. You only have a prototype. It may have a limited utility and output. So there can be devices which have input and output characteristics, and this device may not be able to give all the outputs. It may be able to give only one output. I'll give you an example. For instance, uh, you have created a touch screen entertainment system for a car, which is innovative. Now, the only function that is working at the prototype level is that you are able to play an FM radio on your device. But probably you're not able to work with a Google map, because Google map is also important when you drive a car. So you may have a limited functionality, a limited utility, or a limited output at the prototyping stage. It is acceptable. It is possible that you designed or you had the idea conceived for a particular situation, a particular environment. It has to be used in a particular place. For instance, a machine designed to be used in a factory, and the factory may not have air conditioning, they have air cooling systems. But you are creating it inside a lab which has air conditioning. So there can be limited compatibility with targeted environment, but that is not so important. You can ignore it. A good visualization. So a prototype once created gives a very good visualization. So if somebody looks at your prototype, he should be able to visualize as to what is it, or what is it going to be used for, or what is the estimation of something coming out of this prototype. So a person should be able to visualize or estimate, and a user for sure should be able to visualize and estimate, because when you create a prototype, you also explain or demonstrate the prototype, and then it becomes easier for the other party to understand what have you created, what is coming out of it, what benefits them, is it really good for them. And at the end, the demo and explanation is required, because the prototype may not spell out everything by itself. So if you created a furniture, for instance, then a piece of furniture may look similar to many other furnitures available in the market. But unless you explain the intricacies of the furniture, you explain the comfort levels, you explain the materials, the compatibility with human comfort. Once you explain that, then only it becomes a convincing argument in front of the buyer or your audience. So therefore, demonstration and explanation is required, because prototype in itself may not convey all the aspects or features or innovative aspects of its design to the user. It has to be explained. That's the reason why the marathon requires you to submit a prototype. Remember, you can only convince the users if you have really solved their problem. And in my earlier slide, I talked about the problem statement. The problem statement actually is very, very important. I'll give you some examples. Sometimes people write the statements in such a way that they are asking a question. Like, I'll give you an example, how to conserve fuel while driving. Okay, so this is one way of stating a problem, that there is a problem in your device that you are not able to conserve fuel. It is consuming a lot of fuel. The other way of putting this same problem in a statement is, fuel average of my vehicle is low. So you are making a statement that this is the problem. You are not asking how to solve. You are saying, this is my problem. So in my opinion, this is a better way of making a problem statement. Another example, how to solve problem of water overflowing from tanks. Now this is a question format, but the better format according to me is, lot of water is wasted in overflowing tanks. Here is a problem statement which is easier to understand, which actually looks like a problem. So rather than asking questions in a problem statement, the better is to make a statement. That's my hint for you. Okay. Now we move to the stages of prototyping. So there is something called prototype. I learned this from Kiran Kumar. Thank you for that. So prototype is a quick and inexpensive modeling. So when you're sitting on the table, you have a piece of paper, you have a pencil, you have some devices to make some shapes, you have a ruler, and you draw something. You draw a sketch, and then you fold it and try to make something which is very quick and inexpensive. So you don't need much of materials, but you can do it right there on the table at that moment. So it is quick and inexpensive. So it's a pre prototype, you can say. So that's the reason it's named as prototype. Then there is initial prototype. So an initial prototype is resembling what you have in your mind to a great extent, but not complete. Then you need multiple user feedbacks while creating the prototype. Again, I'm saying this because you may talk to more than one users, or you may talk to a single user several times. So when you're talking to more than one users, you have multiple user feedbacks. So there is a variety, and that's always better. When you have a single user, probably you go for the iteration, which means that you improve each time you get a feedback, you improve your prototype, you go back to the user, you again improve your prototype, you go back again, and there is a multiple series of feedbacks. So finally you make a final prototype which is functional, so which has all the functionality but may not be finished. It is not a finished product, so it is not ready to launch into the market, but it is ready to demonstrate all aspects of your invention or all aspects of your innovation. So that's how we call it a final prototype, but it's not the product. After final prototype is the product. So what is the success mantra in the process of prototyping? Iterate. So iteration means you started creating a prototype, you went to the user, he suggested something, you came back, you added that, again went to the user, he created something more, he suggested something more, you again improved, again went, and this is a process which is called as iteration. So the more iterations you do, you will have a better result of prototype for sure. Now we come to tools and materials. So the first thing is materials. What materials can we use? There is no requirement of materials from from the lab. They may or may not be in the lab. They may not have been purchased out of the funds received from Atal Innovation Mission, because all these materials are readily available in the market at a very low cost. Let us look at them. Cardboard. We all know it's a very nice item, and it comes in a thickness. It has a corrugation inside. It's made out of paper. It's available everywhere. Here is an example of a cardboard created prototype. It's a sofa. Now, again, I come to the same point. This is looking like a sofa, fine, but this is looking like just another piece of furniture. Now it depends on the creator or the inventor or the innovator, how he demonstrates this piece of creation to the user, because that demonstration will highlight what are the features, how does it solve problems of users. You cannot see those solutions in the picture. The picture doesn't speak those volumes. Only the creator can do that. Now, on the cardboard, I have a small video to share. It's interesting to see how you can create stuff out of cardboard. See this.
So the video is not visible.
The video is not visible?
No, sir. I think probably you have not shared that tab.
Okay. Wait. Share that. There's no X. Yeah.
So if you want, we can skip showing the video.
Wait. Let's try. Yeah, this screen is not going up actually. Something happened here.
Maybe you can unshare and reshare, sir.
That WebEx screen is gone somewhere. I don't know where. Okay, fine. So now I'll share, don't worry. This. Yeah. Is it visible now?
Yes.
Yes, sir.
Okay, sorry for restarting. Okay.
Next, let's talk about ways to attach cardboard. Interlocking scores. If you score two pieces of cardboard, you can slide them together for a delicate but clean hold. If you need to support corners or attach pieces more strongly, you can make tabs, following the fold method, and glue them onto your pieces. Slots. Cut slots into two pieces of cardboard and interlock them. Hot glue. There's always the tried and true hot glue method, but watch your strings. There are also some more novel or niche ideas. For example, squish the cardboard. By doing this, you can make it flat and bendy. Try hiding and showing the corrugations at different points of your object to differentiate textures and components. Lamination. Need more thickness? Stack pieces of cardboard to build up volume. Consider using paper clips or pins as rotation points. So, to recap, use a metal ruler and a sharp knife for clean lines. Score your lines first, then cut all the way through. There are many ways to attach and bend cardboard to achieve the desired appearance. Don't forget to experiment with other things on hand to make more unique, more functional prototypes too. We hope this helps get you started with cardboard prototyping. Thanks for watching!
Okay, so I come back to my presentation. Sure. Okay. Is the screen visible? The PowerPoint presentation is visible?
Yes, sir.
Yes, sir.
Good. So we are almost at the end. Let me move fast to the last slide. We were here. Okay. So we already checked the cardboard and we saw the nice video on how to prototype foam cardboard. We also have foam available in the market. You can cut the foam into various shapes and it has a good amount of thickness and you can select the thickness in the market and buy and cut the components. So if your item has a lot of components, you can cut it from foam also. There are plastic sheets available in the market in various colors and transparent sheets are also available depending on your requirement. There are also Lego blocks. So you can also build using Lego blocks. These are in plastics and they are also available in various colors. There are also pipes available in many of our inventions. We need some cylindrical objects or round objects. We can use these pipes also. So we had the materials. Now we come to the tools and you can see here that if you have a gluing system, you have some pair of scissors, you have a cutting knife, you have some ruler and pencil and eraser and marker, etc. You can do a lot of work with these tools. But always remember that students should be cautioned that safety is very important and they should try to use these safety gadgets, something like a mask, something like a pair of gloves, and something like eye gear. And these are meant for their safety and these are very important. That's all from me, and I wish the best of my wishes to your mentees for their success in the same. Okay, over to Mr. Kiran Kumar.
Thank you, sir. So can I share my screen? Okay, fantastic. Okay, good afternoon, everyone. My name is Kiran Kumar. I'm a regional mentor of change from Karnataka. Today I'll be covering the digital prototyping part of the prototyping activity. Gauri, Dutt sir already explained to you how to build physical prototypes, but we will look at the digital prototyping part. Okay, let me share my screen and then we'll get started. Yeah, hope you're able to see my screen.
Yes, sir.
Okay, excellent. So both digital prototyping and physical prototyping are, of course, they are very different, but having knowledge of both of them is very crucial because sometimes you may have to go for physical prototype, sometimes you may have to go for a digital prototype, sometimes you may have to use a combination of them. Okay. So let's go to the next slide. So we'll look at three different types of prototypes. First, Gauri Dutt sir already explained to you about the physical prototypes, which requires physical resource materials. So sir already explained to you many types of materials, cardboard, foams, plastics, and many other type of materials. Okay, that you're already familiar with. I'm not going to delve into the physical prototypes, but I'm going to cover two other types of prototypes. One is called the digital prototype, and the third is called the hybrid prototypes. Okay, so what is a digital prototype? A digital prototype is basically anything that you build with software tools and technologies. They can be, they're not in the physical 3 dimensions, but they can be experienced using smart devices. It could be like a smartphone, it could be using a computer, it could be using some augmented reality or virtual reality headsets, or it could be a smartwatch, or any of these devices it could be experienced. Okay. And of course, the completed functional prototypes can be experienced using these devices, but you can also, some of them can be simulated in software itself. So we're going to come to that as well. So there are two main reasons for building digital prototypes. One is, let's say you are trying to build a mobile app, or let's say a website or some other software. There's no need to build a physical prototype, right? Because these are completely software-oriented, software-based products or solutions. So in which case you go for a digital prototype. So it's pretty obvious. The other reason for going digital prototypes is when you have a physical solution or a physical product, but you are unable to build it for some reason or the other, in which case you want to represent it virtually, maybe like a 3D model or something like that. Then that is another reason where you go for a digital prototype. Okay, so you basically use digital tools and technologies, software-based tools and technologies for building digital prototypes. And the third type of prototype is called hybrid prototype. So as the name implies, it's a hybrid of both physical and digital prototypes. You use a combination of physical resource materials as well as software, programming, electronics, and things like this. You put all of them together and then you build prototypes. An example of this would be like a mobile phone app controlling a robot which moves around. You can make the robot move around. Okay, so I'm going to give you some examples of digital and hybrid prototypes, and then we'll also discuss a few techniques for digital prototyping. Okay. So what are some of the examples? Let's say you want to build a mobile app. Of course, you can use a mobile app development tool. Like it could be MIT App Inventor or Codula or maybe some other tool that you could use. If you want to build a website, you could be using Google Sites or Wix or some other website building tool. And you could, many of these tools also give you ready-made templates using which you can rapidly build some early versions of your prototype without much effort. So that is one advantage of using these online platforms. Many of them are free to use. And they're also, let's say you want to build a virtual reality or augmented reality experience. There are again online tools for this, software-based tools using which you can build these early versions of the prototype. Or you could build a chatbot, or you could be building, let's say, a video. So all of these are different types of digital prototypes. Even a video or animation video or a 3D model, all of these can be digital prototypes. And you can build them using the software tools and applications, and you have two ways to run them. One is you can either simulate them in the designer software itself. For example, all these mobile apps can be simulated. You don't have to even install it on a physical device like a smartphone. You can simulate them within the environment of the designer or the editor in which you're building the mobile app. And then if everything is great, then you can probably download and install it on a physical device. That is one way to do it. Okay, so these are some of the examples. And coming to hybrid prototypes combine software tools, programs, code, electronics, and other physical prototyping kits to build richer prototypes. And the advantage of this hybrid prototypes is they work. They are more functional than probably dummy physical prototypes because you are using technology and embedding them with the physical resource materials. You're making that physical resource materials more interactive. A robot can move around and do something rather than a dummy physical model, which might just be sitting there. It may have some wheels, we maybe have to push it manually, but if you put some programs and things like that and some electronics on it, the robot might actually start moving around and you can remotely control it from a mobile phone and things like that. So you could be building robotic prototypes or electronic or IoT prototypes. You can be building drone-based prototypes or even scientific prototypes. So all of these could have an element of physical as well as software-based elements in it. So there are different ways to build different kind of prototypes. So now for your software, the school innovation marathon, you need to be clear of what kind of prototype you want to build. Is it like a physical prototype or it's a digital prototype or a hybrid prototype? So a hybrid prototype I can tell you, it gives you richer experience. But of course, sometimes physical prototypes are more suitable. Sometimes only digital prototypes are more suitable. But if you can combine both of them, it gives you greater experience. And ATLs have a lot of resource materials for building hybrid prototypes. Let's go to the next slide. So now I'll talk about some of the digital prototyping techniques, some of the most prominent or common digital prototyping techniques. We call them as, one is called wireframing, another is called creating screen mockups. The third one is called 3D modeling. The fourth one is a simulation, or you can also create explainer or animation videos. So I'm going to talk about each of these 5 different techniques in a little more detail so that you get an idea of when to use what and what each of them entails. Okay. Yeah, so first is the wireframe. So wireframe, you can use this wireframing technique to build prototypes. So what is a wireframe? Wireframe is basically, you can think of it as a sketch. You can draw it on a piece of paper with a pencil, or you can use some online software tools to create wireframes. And these are like rough representations of, let's say, a mobile app or a website that you want to build. So you can use, if you're using an online tool, you can just create some screens or boxes. You can call them as boxes. You can drag and drop some box and that box becomes a screen, a mobile app screen. And then within that box, you can drag and drop some menus. You can drag and drop some text boxes, buttons, images, whatever you want to put. So as you can see in this picture here, this is a very rough way of doing it. Of course, the buttons and the images may not be looking realistic, but it gives you a rough representation of how your prototype will look like. It enables you to bring your idea to life. Not in a real sense, but at least it helps you visualize your idea in terms of screens, in terms of content that you want to present in your digital product or solution. So that's what a wireframe is. There are, of course, many tools like mockups, Figma, Just in Mind, the Lucid charts and things like that. You can use many of these. If you have only a few screens in your app or a website, you could just be drawing these wireframes with just a piece of paper and pencil. It's not difficult to do it. But if you have many of them, many screens, and you want to show different flows between different screens, how clicking one button would take you to another screen, or selecting some menu would take you to another screen, things like that, then an online tool will become much more comfortable to use, easier to use. You can complete it much faster. So this is a very rough representation. And there are certain times where you need to use wireframes, or you can actually start your design with wireframes before you actually build a fully functional prototype. Okay. So just keep in mind, maybe you can just, if you have a piece of paper or pen, you note down these points that I'm highlighting and check out these tools and see how you can utilize these tools for building these kind of wireframes. These are different stages in which you build a prototype. Initially, you start with a wireframe, then maybe you can slowly graduate to screen mockups. What is the difference between a wireframe and screen mockup? The mockups are better looking. They have color, the buttons look more realistic. The menus also look more realistic, as if it is a regular mobile app. So it looks very real, but it doesn't really work, or it hardly works. Maybe it works very little, in the sense that most of the content that you see on the screens are all dummy screens. They are not really real content. They're not dynamic content. You just hard code this content or put some text and put some images, dummy images, but it gives you the representation of as if you're seeing a real app. Maybe some of these buttons you can also make when you click that button or tap that button, it actually goes to another screen. That little bit of functionality you can build into these kind of mockups. Beyond that, they don't serve much purpose, but again, it helps you to get a sense of how your app will look like, and it helps you to communicate your ideas to somebody else, maybe the jury members of the innovation competition or somebody else in your school, wherever you want to present this, you can showcase this. The thing is, wireframes and creating screen mockups don't take you much time. They are very rapid, but you can say they're initial form of prototypes. They're dirty prototypes before you can actually build more sophisticated or functional prototypes. So there are tools like Figma, MIT App Inventor, Codilla, Thunkable. All of these can be used for building mockups for mobile apps. And of course, if you have time, you can also enhance those mockups further and build functionality and make it a full functional prototype also. And if you want to build websites very rapidly, there are templates that are readily available with tools like Google Sites, Wix, Squarespaces, and things like that. These tools will give you ready-made templates. You just select one template and the website is already ready. You can just customize a few content here and there or change some images and your website prototype is ready. So they allow you to rapidly build some mockups. They may not be fully functional, but they allow you people to visualize your ideas very quickly without spending too much of time. So these are the second type of second technique. The third technique is modeling, 3D modeling. You can also use 3D models to create prototypes. What is the advantage of 3D modeling? One is a 3D model is nothing but a virtual representation of a physical object. Let's say you are unable to build a physical prototype, in which case you can create a 3D model version of the same physical object or physical prototype. So there are tools like Tinkercad, there are tools like Blender, AutoCAD. There are even Lego-based 3D modeling tools like Mechabricks and Bricklinks. All of these tools you can use to rapidly build some 3D models. And of course, they give you either realistic or semi-realistic representation of a physical object or scenario or things like that. So if you want to create a 3D model of a rocket, for example, what you see on the right side, bottom right side, you can create that using Tinkercad very easily. Just drag and drop a few blocks and change the shape and size, and you can create a rocket. If you want to create something like a rabbit, you can just drag and drop a few Lego blocks using Mecha Bricks or Bricklink Studio. You can create 3D models like these. So the advantage of 3D modeling is before you actually build the physical prototype or physical product, you can build it in 3D, see how it looks like, how it feels like, and maybe if there are some mistakes, you can correct them in the 3D model, because it's a lot more easier to correct them in software rather than once you build it. Okay, if you build it and something is not right, then fixing it will take you time, effort, money, everything. So building 3D models helps you that way to fine-tune things before you actually physically build it. And let's go to the next one. Simulation. Sometimes you may not have access to physical resources, physical tinkering resources or innovating resources, or you may not even have an ATL in your school. What do you do in that case? Or if you have ATL in your school, maybe you're unable to access some of the tinkering resources in the ATL because of a lot of restrictions. Typically, innovating will take you many weeks or many months, and then you may not be able to go to the ATL all the time. So what do you do in that case? How do you build your prototype? So fortunately, there are tools, simulation tools. For example, there are tools, another tool from Tinkercad called Tinkercad Circuits, using which you can simulate Arduino circuits. Arduino, sensors, actuators, all these electronic components, everything can be simulated in software. As if they're physical, real Arduino boards, you can actually simulate them. And you can make the Arduino, connect a wire to the Arduino board, connect some LED or some sensor, some actuator, write some programs, and click a button, and it will show you how the Arduino board will work and how it functions. The LED will glow, some servo motor will rotate. All of these things can happen in software itself. And it's fantastic if you can use these kind of tools. There are also tools for designing and, let's say, flying rockets. How else will you build a real rocket? Your ATL may not have any resource materials for building a rocket, but if your innovation involves using some rocket, then Open Rocket is a tool for you to go. It is fantastic. You can create nice looking rockets, multi-stage rockets, booster rockets, and all of those. Or if you want to build a drone, or if you want to build a robot, there are again tools for that. Eduvance is a good tool for simulating drones, and you can fly drones using the Eduvance tool. Or you can use the iRobot code, which will help you simulate basic movements of the robot. So there are many simulation tools like these, and they help you illustrate the actual functioning of the physical solution, physical product or solution in a virtual way. Okay, once you're convinced, then maybe if it is possible, you can build the physical version. If not, you can restrict yourself to the simulation and demonstrate that itself. And the next version, the next type or next technique of digital prototyping could be as simple as creating an explainer video or even an animation video. Let's say you don't have any time. You're hard pressed for time and you're unable to create any physical or other types of digital prototypes. You could just explain the concept of your idea or your innovation in the form of a video. Very simple video. You can just stand there and you can explain, or you can use some images in Canva or some video clips that are already in Canva or sourced from some online sources. You can put together and you can create a simple video. Or you can use Animaker tool. Using Animaker, you can actually create fantastic animated characters, scenarios, scenes, everything. You can put them together and you can tell a story. These are all, again, not really functional prototypes, but helps you explain your idea better. Rather than just putting some slide deck, which you can also do, of course. You can, even in PowerPoint, you can create some simple animations and present them. But these are slightly better. So again, when do you use what kind of technique or tool? So we'll get to that now. Of course, before that, let me also conclude the techniques by saying that these techniques allow you to create different levels of prototypes. Some as like a wireframe, which is very, very basic. Screen mockup is slightly more enhanced. A 3D model will help you to represent physical objects in virtual environment. Similarly, the video and animation videos are again storytelling techniques. And animation is also, what is the other one? Simulation. The simulation also helps you just simulate. But if you want to build a full-fledged functional prototype, you can use all of these tools. All of these tools will also help you build functional prototypes, many of these tools that I mentioned earlier. Forget the wireframes and the screen mockups, but most of the other tools will help you to build a functional prototype, fully functional prototype. If you take an animaker, you can create a full-fledged animation. If you want to create a chatbot, there is this landbot. If you want to create a virtual tour, you can use ThingLink. If you want to create augmented reality experiences, there are ZapWorks. Or you can create games using MIT Scratch or Teachable Machine or the Plasmo AI Coder. You can use these tools for building AI-based digital prototypes. And they can be full-fledged prototypes. They do really work. So don't stop at the wireframes or screen mockups. Go further if you have time and try and build fully functional prototypes, because that is what will be appreciated, especially in School Innovation Marathon. The more functional your prototype is, the better it stands a chance of getting selected also. Okay. Now let's go to the next question. How do you choose which prototyping tool or technique to use? Again, these all depend on multiple factors. One of them is the time available at hand. Okay. So how much time do you have? If you have very little time, you may have to go for wireframe or screen mockups only. But if you have a little more time, then you could do something more like an animation, or you can build a full-fledged, fully functional prototype if you have more time. And again, it also depends on what you need to prove or demonstrate. So what is that you want to prove? If you just create a video and if you just explain the concept, that may not necessarily be always possible. Somebody may have doubts about the technical feasibility of building the solution itself. In which case you need to decide, okay, I need to prove that it really works. My idea really works. That means you need to build a functional prototype at that point in time. If you just show a screen mockup, people may not be convinced about it. And the suitability of technology or tool for prototyping, that is also another consideration. If your solution idea is very complex, then maybe the kind of technology that you're using may or may not be suitable. And you may not even have access to that particular tool or technology. So all of these will influence your decisions on what kind of prototyping tool or technique to use and what kind of prototype you need to build. And feasibility of implementation also. If it is going to take a lot of time, lot of effort, lot of complexity, then feasibility of building the prototype itself is questionable. And how much time you have, all of these factors will ultimately influence your decision. And most importantly, these are some of the things that students always miss out. The knowledge and skills. If you don't have the right knowledge, if you don't have the right skills to build the right kind of prototype, if you don't know how to use the resources, tools, or technologies, you'll not be able to build it. Many a times students come up with grand ideas, but they really don't have the knowledge or skills of how to make it work. In which case, what happens? You can at the most probably show some video, an animation video or a simulation. You can't go beyond that. You will not be able to build a functional prototype if you don't have the knowledge and skills. And this can come as a surprise to many of you as you start building the prototype, then you realize I don't know how to do this or how to do that. And availability and affordability of prototyping resource materials. That is also a consideration when you build the prototype. Does your ATL have the resource materials? If not, what do you do? Will you buy it on your own, or will your school buy it for you? If it has to be purchased elsewhere, it's going to take some time. Do you have sufficient time? All of these, and how much does it cost? All of these will you need to take into consideration. That's why for many of these decision making, you need to work closely with your teachers and mentors. They can help you decide whether it's feasible, not feasible, whether it can be done, not done, whether resource materials available in the ATL or not. They can help you take those decisions. If you don't consult any of those teachers or mentors, you may be in for surprise later on. And ultimately, you also need to know the expectations of the judges or the jury members in the innovation competition, or anywhere you want to present it. Your audience, you need to know your audience and what do they want to see in your prototype. If there is a mismatch between what you are building and what you're showcasing and what they expect is different, how can you aspire to win the competition or win something else, right? It's not possible. So you have to take into consideration many of these things. That's why please do work with your teachers and mentors as closely as possible. Okay. And let's go to the next one. So I'll give you some tips and suggestions for prototyping now. the last 1 or 2 slides. And the first tip is be very clear on what you want to showcase. Set clear goals and objectives. What is that my prototype has to do? What is that I want to showcase? What is the end objective? All of these you need to be clear. You need to write it down. If you don't write it down, then you will have surprises as you go along the journey. And maybe you'll not be able to complete your prototype by the deadline, and what you submit may not be up to the mark. And then if you say that, oh, my prototype didn't get selected, my idea didn't get selected, who can you blame, right? Not possible. You can't blame anybody else. And having right skill sets is very important. If you don't have all the skill sets, make sure that you acquire them. If it is possible to acquire them in a short period of time, do acquire those skills. Or please at least go and consult your teachers or mentors who may have those skills, or who can at least put you in touch with people who know those skills, so that they can guide and support you through your prototyping journey. So you need to fill that gap before you start prototyping. Otherwise, again, surprises. And list down the resource materials. Many times we start building prototype without knowing what resource materials are required, whether they're available, not available. If not, if we have to purchase, how much time it takes. And again, we'll have surprises, right? If we don't do a good homework with all of these things. And put a schedule, put a plan and put a schedule of identify all the tasks that you and your team members had to complete to finish your prototyping. Have start dates and completion dates, and assign ownerships, and track the progress of your prototyping activity on a daily basis. If there is a delay in one activity, it can impact the other activities, and subsequently your prototype may not come out as well as we expect, or it may not even be complete by the deadline. Okay, so it's very, very important. And what's the next one? Build a prototype that adequately addresses the problem statement. This is one common mistake that students do. They have written some problem statement, but when they actually build a prototype, it hardly implements the solution for the problem statement. There's a huge disconnect. Problem statement is grandiose, but the prototype is very piddly. That means there is no connection between what you're saying your problem is and your prototype is. So you need to demonstrate effectively how your prototype solves the problem or the user's need. If it can't demonstrate sufficiently well, then there's no chance that you will get selected in the top 100 or top 500. And finally, I would say come up with a checklist to ensure readiness of your prototype and know what are the rubrics or the evaluation criteria. If you're submitting for the Student Innovation Marathon, you need to know what are the rubrics, or how do the judges evaluate. What do they give importance to? Do they give importance to your innovativeness? Do they give importance to your technical implementation? Do they give importance to the problem statement? How well you have understood the problem statement? Do they give importance to how you're demonstrating it, how you're showcasing it, how you're documenting it, and what are the weightages for each of these criteria? So how much you need to spend on innovation, how much you need to spend on technical implementation, how much technology you need to showcase, all of these you need to be very clear. Otherwise, what you build and what the jury will expect will be a lot different, and ultimately you may not get selected. So at least if you have your own checklist, then at least you can be, you yourself can determine whether your idea will get selected or not, whether your prototype will get selected or not in the top 100. And lastly, at least you can get your parent, teacher, or mentor to give you some feedback. Get some honest feedback about your prototype and overall submission. The feedback you receive will help you refine your prototype. You need to set aside some time for all of these, getting feedback, refining your prototype. If you just build the first version of the prototype and submit, it may not be the best prototype. So then you can't expect to be in the top 100, top 500 unless your idea is really fantastic. And the jury members still consider your idea in the top 100. So you need to please pay attention to these tips. Take a screenshot if you want, or I would say I have given you certain QR codes and screenshots. Take the screenshot of this screen. If you want more information on problem solving, innovating, prototyping, I have put together this web portal. You can click this link or scan this QR code. Or if you want to download some templates on how to plan your prototype and how to execute your prototype, how to build your prototype, again, I have some templates. So scan that QR code and you will be able to download it. Or if you want this slide deck itself, again, you can download it by scanning the QR code at the bottom. Okay. So take a screenshot of this, save it, and then maybe later on you can scan the QR code. Okay. So that is pretty much what I wanted to cover today, and I hope it has added value to many of the students in the audience. And I wish you all good luck and best wishes for your submission for the Student Innovation Marathon. And let me hand over the session back to Ms. Riddhi. Thank you.
Thank you, sir, for this insightful session. We are receiving a lot of questions through WhatsApp, and due to time crunch, we would be able to take only few of them. So, like, first question is, what are the most common tools that we can use for prototyping, and can you please suggest some free softwares that we can use for rapid prototyping and 3D printing?
Okay, in fact, all the tools that I mentioned in my presentation today, they're all free software tools. And we have given exposure to all these tools as part of the Tinkerpreneur Bootcamp. So those students who have already attended the Tinkerpreneur Bootcamp, they will know how to use these tools. Otherwise, on the last slide, I gave a link to a website. Within that website, I've also not only talked about problem solving and innovating, but there is one web page within that portal which gives you tutorials on how to acquire skills in many of these tools. How to create a chartboard, how to create a 3D model. There are step-by-step tutorials. The same tutorials that you find in Tinkerpreneur, you can find it here also. Students can go to that portal, they can find the tutorials and they can acquire. All the tools are free.
All right. Then again, the next question was about tutorials only. So you have covered in this part only. So that's it. So I would like to thank both the sirs for taking out time and sharing the insightful session. And I'll insist all the audience that they leverage these resources, learning resources, and ensure maximum participation in School Innovation Marathon and other initiatives taken up by Atal Innovation Mission. Thank you all, and stay tuned in for more such sessions. Thank you very much.
Thank you, ma'am.
Thank you very much, Riddhi.
जब आदमी आई नहीं क्या करेंगे हर चीज को घटा दिया भाई आ गया दवा नेक्स्ट टाइम